Now we're going to look at rectification using diodes. Now, we know about current. It can be either direct current, DC. In a direct current, the electrons flow in one direction only around the circuit. So usually the voltage stays constant and the current would only be in one direction. A trace on an oscilloscope will look like this. Alternating current means that the current is changing direction all the time, and it looks like this, like a sinusoidal wave. The voltage oscillates between negative and positive, producing this kind of typical waveform. Now, from AC to DC. Now, AC, alternating current, is used to carry electricity around the country. Basically because its voltage is easy to change using transformers. It requires a simple generator. However, most modern appliances in our home now use microchips. And most microchips need a very steady DC with a near constant voltage to function. This means that we must convert the AC, which is a system by which we transmit electrical energy, from the mains to DC in order to use them in our appliances, computers and so on. Now there are two major steps required to convert an AC signal to a DC signal. The current must go in a constant direction. Any kind of variations in voltage must be removed. So we have rectification. This is the process which basically turns AC into DC. So we have to start with this sinusoidal curve here, and if you notice that we basically made it all positive, so it only goes in one direction. So the signal produced is an imperfect DC. It goes in one direction, but there is a variation of voltage. Now, if we use a diode, this is how we obtain this DC. So we'll press play to find out how. First of all, we have AC going through this circuit by the input. Notice that it's going from to the left to the right, to the left to the right, and so on. So this is an AC circuit. In an AC signal, the signal is running in both directions, and it basically flips between positive and negative. Second stage, if we add a diode, we know that the diode only allows it to go in one direction and not the other. So effectively, we have this half rectified signal here. Half of the signal has been deleted and half of the signal is allowed to flow. Notice the negative current on this side has been removed because it's not allowed to flow in the other direction. So, this one-way gate only allows electrons to flow in one direction. Thus, the trough, so to speak, seen in the input signal are lost on the output signal. This is a half rectified circuit. Now, if we use a combination of 4 diodes called a bridge rectifier, an AC signal can be fully rectified. And this is the setup. Notice that it goes from the diodes point from left to right in this case. We have the circuit going to this system of diodes. The load is between the first and the last diode there, and that's connected to a CRO. So this is the input signal, a fully rectified signal here. The output signal always has a positive voltage, meaning that unlike half rectified signal, no energy is lost. Now, to understand how this is going to work, we use this graphic here. Now the current is going to go this way, and we know it can't go in this direction. It has to go through the B, it goes across there, and then it goes through C around the circuit this way. So stage 1. the electrons leave the power supply and they go in this direction. They can't go through A and D because those diodes are pointing in the other direction. So this is the direction they're able to go. Diode B directs the current through the resistor. Diode C provides the path of least resistance back to the power supply. Then the current will go in the opposite direction. When currents leave the power supply from the bottom, diode D directs the current through the resistor, and diode A enables it to go back to the power supply. Notice that B and C will always block because they're reverse biased. So if you notice that as it changes direction, the signal will go in the opposite direction. But the current will always go the same direction through the resistor or the load, and this is what is connected to the CRO. So with an alternating current, the diode system ensures that the electrons flow in one direction through the resistor, but the AC at the power supply results in a varied output voltage. So let's have a look at these statements. Rectification is the process of converting DC to AC. Let's try false. It's the opposite. It's from AC to DC. Diodes are used to rectify a signal as they only allow current to pass in one direction. True. Half-wave rectification produces a signal with periods of 0 voltage. That's true. Full wave rectification requires a system of 4 diodes. That's true. Full wave rectification produces perfect DC. No, that's not true. It's not perfect DC. It's still a varying voltage, but always in a positive direction. Microchips can be run on the output signal of a bridge rectifier. That is not true. There has to be a very smooth current. Let's solve. Yes, there we go.